Today's video will be on section 1.4. Today's goal will be
learn about Venn diagrams to distinguish between exclusive and non-exclusive events. So, what is a Venn diagram, Ms. Penna?
Well, a Venn diagram is often used to graphically describe the relationship between events. We will use them to organize the probability of events in a similar fashion to our previous examples while working with sets of data.
In the diagram that you see below, we are shown that two events, A and B, could both happen at the same time. This is similar to intersection of sets that you may have studied before. In this case, the events A and B are considered not mutually exclusive. Using your pencil or pen, you can shade in the area in the diagram that indicates the probability that A and B could both happen at the same time.
And in this diagram, the events A and events B are mutually exclusive events, or we can say just disjoint sets, as A and B do not have any elements in common. So the probability of the intersection of A and B, so that's written here, is equal to 0. In other words, these events cannot happen at the same time.
So now we'll focus on the idea of events being mutually exclusive. Mutually exclusive events are events that cannot occur simultaneously. If one event has occurred, it is not possible that the other occurred at the same time.
But wait, Mr. Langford, I don't get it. Can you give me some examples?
Okay, let's say I have a single die with 6 sides on it and I roll it. I can't get a 1 and a 2 at the same time. So the event of rolling 1 is mutually exclusive from the event of rolling 2.
Oh, okay. So since the sets are disjoint, is it true that when we have the probability, should we add them?
That's right, Ms. Penna. The addition rule for mutually exclusive events says that the probability of the first event added to the probability of the second event will give us the probability that one or the other event occurs.
Now let's take a look at an example. Example 1. If 2 standard dice are rolled, what is the probability of rolling doubles or a total of 11?
For a solution to a problem involving rolling 2 dice, it's nice to have a picture of the sample space that's involved. So here we have the typical sample space for a 2 dice roll showing all 36 possible rolls. If you search through the sample space, you can find incidences of doubles. For example, if I roll 1 and 1 on each die, the sum is 2. If I roll a 2 on each die, the sum is of course 4. And if I go down the diagonal of the sample space, I can circle all of the rolls that are doubles. So we know there are 36 numbers in the space altogether, so our probability of doubles is going to be 6 over 36. Similarly, we can search through the sample space and find all the sums that are 11. There's one, and there's another one. In both cases, we are summing 6 on one die and 5 on the other. So that makes the probability that our total is 11, 2 over 36. So if we sum the probability of rolling doubles with the probability of a total of 11, we'll get the probability that the roll is either doubles or 11, since these events are mutually exclusive. You will notice that the red circles indicate doubles and the green circles indicated 11s, and there's no number that has both a red circle and a green circle. That's how we know they're mutually exclusive.
Now we're going to move on to example 2. Try this question on your own. Example 2. You're at Costco waiting in line for a free candy sample. The Costco salesperson is pulling sample bags out of a bin with a total of 87 bags. There are 32 bags of chocolate-covered almonds, 27 bags of gummy worms, and the rest are licorice. What is the probability that you will receive licorice or gummy worms? C. Non-mutually exclusive events. Non-mutually exclusive events are events that may occur simultaneously. If one has occurred, it is quite possible that the other has occurred at the same time. Consider this. We are looking for the number of ways to select a queen or a heart from a standard deck of cards. Since you could select one or the other or both simultaneously, so that is a queen of hearts, these events are not mutually exclusive.
So if the events are not mutually exclusive, when we find the probability of either A or B happening, there's a problem. We have a situation now where some of the probability of A is overlapping with the probability of event B. So when we add the probability of event A to the probability of event B, we would have a larger probability than is correct. In essence, we would have included the overlapping section of the Venn diagram you see below twice. That means we're going to have to subtract that probability of A intersection B from the sum of the two probabilities. So we take the probability of event A, we add the probability of event B, and then we have to subtract the probability that both A and B happen together. So if I'm rolling a pair of dice and I want to know what the probability is of rolling either doubles or a total of 10, how do I figure that out?
So in this case, rolling a 10 and rolling doubles is a non-mutually exclusive event because we can roll a 10 by rolling doubles because 5 and 5 would equal 10 and 5 and 5 is rolling doubles. So first let's take a look at what the probability of rolling doubles is. So the probability of doubles, which I'll note with P of D, is equal to, like in the last question, 6 over 36. Now let's take a look at the probability of rolling a 10. So the probability, our 10, is equal to 3 over 10 over 36. And now let's consider the probability of these two events happening at the same time. So the probability of rolling doubles and the probability of rolling a 10. Now this is just 1 over 36 for the case of 5 and 5, which is both doubles and summing to 10. And so let's consider the formula that we just learned. So the probability of rolling doubles or a 10 is of course equal to the probability of rolling doubles plus the probability of rolling a 10, subtracting their intersection. So since we found the probability of all of these things, we can just put that in here. So the probability of rolling doubles was 6 over 36. The probability of rolling a 10 is 3 over 36. And the probability of rolling a doubles that sums to 10 is 1 over 36, because that's 5 and 5. And when we add the first two values and subtract the final value, our final answer for the probability of rolling doubles or rolling a 10, a total of 10, is equal to 8 over 36.
In example 4, we consider the probability that coyotes attack you on your walk home from school. That probability is 0.01. The probability you will get your lunch money stolen is 0.2. Consider these probabilities and answer the questions below on your own.
Also on your own, consider example 5 from when Mr. Fox is moving into his new home.
A suggestion for the solution to example 5 is to try and draw a tree diagram where you show the probability of getting sprayed by the skunk or not in the first level, and the probability of being pricked by the porcupine or not on the second level.
Alright guys, do your best with these problems and we'll see you in class for more work.